Okay, this is section 3.6, polynomial and rational inequalities. So first let's take a look at what these are. Start with polynomial inequalities. Let f of x be a polynomial, then a polynomial inequality is an inequality of the form f of x is greater than or less than or greater than or equal to or less than or equal to 0. Alright, to solve, we can follow this procedure to solve symbolically. Find the zeros of f of x, use the zeros which we will call boundary points to separate the number line into intervals, and then test a point from each interval to check the sign of f of x on that interval. Okay, let me zoom in a little bit. Alright, so first notice we want to write it as 0 on one side of the inequality, and then whatever polynomial is there, we'll call that f of x. That's what that tells us up there. Alright, so here I'm going to subtract 6x, so I have then x to the third plus x squared minus 6x is less than 0. Alright, and so my f of x is x to the third plus x squared minus 6x. I will find the zeros, and I can factor out in x first, and that leaves me x squared plus x minus 6, and I can factor that. This will be x times x plus 3 times x minus 2. So I have three factors, that means I have three zeros. X equals, from the factor x I get x equals 0, from the factor x plus 3 I get x equals negative 3, and from the factor x minus 2 I get x equals 2. And those are going to be my boundary values on my number line. So if I draw a number line and include those boundary values, so I'm going to have, let's say, 0, 1, 2, 3, 4, 5, and 2 is there. 1, 2, 3, 4, 5, and negative 3 is there. Okay, so and I'm going to, what I'm going to do, and this is something I do for myself, I plot the zeros with solid dots. Okay, so negative 3, 0, and 2, those are my zeros of my function. And I'm going to put a symbolic little fence with a dotted line up. So those are three little fences. Okay, and they just better delineate my borders. Okay, so I've chopped this up into 1, 2, 3, 4 intervals, and each interval will have its sign for the function f, whether the function is positive or negative. All right, I'm going to write my function over here. I'm going to say f of x equals x times x plus 3 times x minus 2. Okay, and then I'm going to pick some values of x in each interval. So for the interval from negative infinity to negative 3, I'm going to pick f of 100. And I don't really want to evaluate f of 100. I just want to, negative 100, I'm sorry, negative 100. I just want to know the sign. Remember, that's what we're looking for. So this is negative, right, for x. Negative 100 is negative. For x plus 3, it's negative. And for x minus 2, it's negative. So f of negative 100 is negative. Yeah? Well, not negative 1, just negative. Alright, so I'm going to mark it negative right there. Alright, f of negative 1, let's say, f of negative 1, again, remember I just want to mark the sign, so x would be negative because it's negative 1, x plus 3 would be positive, x minus 2 would be negative. Oops, I'm writing a number positive and negative, okay, just the signs. And that would give us a positive result. So from negative 3 to 0, f is positive. From 0 to 2, I'm going to find f of 1. Okay, so the first x is positive, x plus 3 is positive, x minus 2 is negative, and that gives us a negative result. Okay, and then finally from 2 to infinity, I'm going to pick 100. Notice 100 just makes it easier for me to figure this out. So the first one will be positive because it's positive 100. Then 100 plus 3 is positive, and then 100 minus 2 is positive. So the result is positive. Okay, I have found the signs. And so what am I solving? Well, these two inequalities are the same. I'm actually solving the second one, but whatever I get for the second applies to the first. So I'm solving where it's negative, less than 0. And so that would be from negative infinity to negative 3, union 0 to 2. Okay, that'll be my answer. Negative infinity to negative 3. Oh, do I include the negative 3? No, because we're not looking for where it's equals. Negative infinity to negative 3. Union 0 to 2. And again, if it said less than or equal to, then I would have included the endpoints there, the ones that apply. All right, let's try the second part, rational inequalities. Okay, so rational inequalities. So let f of x be a rational expression. That means f of x equals p of x over q of x, and p of x and q of x are both polynomials. Then a rational inequality is of the form f of x greater than 0 or less than 0 or greater than or equal to 0 or less than or equal to 0. And again, what that's telling us is we want to write it with one side equal to 0. All right. To solve, we find the zeros and the points where f of x is undefined. And we're going to call those our boundary points. We use the zeros and boundary points. Maybe we should just say use the boundary points to separate the number line into intervals. And then finally test a point from each interval to check the sign of f of x on that interval. Sounds like the same as the other one. Okay, so zeros, where do the zeros of this function come from? Well, from the top really, okay? Or you could write it equal to 0, and if you multiply by x minus 3, you get 2x plus 4 equals 0. In fact, I'm going to factor this, and it'll make it a lot easier to see. X plus 2. So the zeros would be x equals negative 2. That's all the zeros there are. And it's undefined at x equals 3. Okay, so those are my two boundary values, x equals negative 2 and x equals 3. Going to do the same thing. Going to set up a number line. There's 0, 2, 3, 4. That's negative 2. And 1, 2, 3, 4. And that's positive 3. Okay, now, for the zeros, I'm going to put a solid dot. And for the place where it's undefined, I'm going to put a hollow dot. Right? Okay. Or not shaded. Alright, and then we're going to do the same thing. I'm going to put my little fence. And I'm going to write my f of x is 2 times x plus 2 all over x minus 3. And then I'm going to find f of something to the left of negative 2. I'm going to call that f of negative 100. Yeah? And again, I'm just checking the signs. Okay, so the signs, when I plug in negative 100, negative 100 plus 2, so 2 is positive, x plus 2 will be negative, and x minus 3 will be negative. The result will be positive. So on this end, all my values of the function are positive. Between negative 2 and 3, I have 0. I'm going to use that one. F of 0 will be, so the 2 is positive. Notice it's a 2. 0 plus 2 will be positive. 0 minus 3 will be negative. The result is negative. So negative right there. And then to the right of 3, from 3 to infinity, I'm going to pick 100. So f of 100. Notice again, I'm just interested in the sign. The 2 is positive, x plus 2 is positive, and x minus 3 is positive. That's a positive. Okay, and I want to answer where f of x is less than or equal to 0. Well, that's right here. Okay, notice I'm going to include this endpoint over here. But I cannot include this endpoint because that's undefined right there at x equals 3. So there's no point on the graph there. So my answer is from negative 2 to 3, including x equals negative 2, not including x equals 3. And that's my answer to where it's less than or equal to 0. Okay? All right, let's try the back side here. So other inequalities, so look at that one right there. Looks a little different. And that one right there looks a little different, but we will try the same approach. Okay, so first I want to make this equal to 0, so I have the square root of 2x plus 4 minus 2 is less than 0, and then I'm going to find the zeros. Okay, and maybe I also want to look at the domain. Okay, so we'll come back to that, which will tell us places where this is undefined. Okay, so first, in order to find the 0, so we'd have the square root of 2x plus 4 minus 2 equals 0. And I'm going to add 2, so it's the square root of 2x plus 4 equals 2. If I square both sides, I get 2x plus 4 equals 4. So 2x equals 0. So x equals 0. Yeah? And we also need to know that 2x plus 4, right? So So 2x plus 4 has to be greater than or equal to 0. Yeah? So 2x has to be greater or equal to negative 4. X has to be greater or equal to negative 2. Okay? So if I draw a number line, 0, 1, 2, 3, and 1, 2, 3. And so x equals 0 is a 0. Yeah? And then x equals negative 2, well, that just means I cannot consider any values to the left of negative 2. Okay? Alright, so my values are going to have to go from there to there. So I still have two intervals, from negative 2 to 0, and then from 0 to infinity. Alright, so if I try negative 1, yeah, and again I'm going to look at this as my f of x right here. Okay? So negative 1, 2 times negative 1 is negative 2, plus 4 is square root of 2, minus 2 will be negative. Yeah? And then from 0 on, let's pick anything really. Let's pick 100. So 204, square root of 204 minus 2 will be positive. Okay? So this is negative from negative 2 to 0, not including 0. So from negative 2 to 0, including the negative 2, not including 0. Alright, and then the last one, absolute value of x squared plus 2 is going to equal to 5. So first I'm going to make it equal to 0 on the right hand side. Alright, I'm going to find the zeros. Okay, so if you remember your absolute values, this means x squared plus 2 equals 5, or x squared plus 2 equals negative 5. If I try to solve this, if I subtract 2 here, I get x squared equals negative 7. That doesn't tell me anything. This one, x squared equals 3, so x is plus or minus square root of 3. Draw my number line. Okay, and I'm going to let you guys finish that one off. So there's your zeros, and then finish off 3 and 4 in class. Okay, all right, so those